So yesterday we will discuss about introduction to Verilog, what is Verilog, why we are using the Verilog, and difference between the Verilog and VHDL, and different abstraction levels. After that we will move to lexical tokens, lexical conventions, in that numbers how we are representing, and then what is the string. String is the group of characters, and then comment lines. After that some identifiers. In that identifiers we have to follow some rules. Okay, don't start your identifier with number and then dollar symbol. You need to start with some variables, and these are the case sensitive variables. Okay, and then white spaces, so you need to represent some blank space or tabs, and new line you can go for the slash b slash t and then slash n. Okay, and then keywords are module, end module, initial, begin, while. So while, loop, something, if condition, else condition, all these are keywords. Okay, you need to study. And coming to the data types, what is meant by data type, what is the use of data type? Every in Verilog code you are using variables. Okay, those variables store some values, that is called as the data type. Okay, data type is a specific range to store value. Okay, specific range or type we store the values. So this can be divided into two types, either net type. Okay, net type is a physical connection. Suppose this is the one OR gate is there and another AND gate is there. So these two are connected to another OR gate. So from this place to this place, we are using some wires. Okay, here wire is used, here wire is used. Okay, so wire is a physical connection. This will not store any value. Okay, wire is a physical connection, doesn't store any value. So just it is used to drive the values only. Okay, there is no capability to store the values, and then it is used for continuous assignments. We have two types of assignments, continuous assignment and procedural assignments. So wire is used for continuous assignment, so that is the wire. And then reg is the used for storage purpose. It can be store some values, like different type of registers are there. So example, reg, integer, real time, all these values are there. Okay, inside the procedural blocks we can use. Okay, so here the reg is a variable which can be used to store some values, and then there is a capability of storing the values. Okay, so that is the use of reg. And we have some logical values. High means logic 0, logic 1 means high value, and logic 0 means low value, and unknown value and high impedance value. So because while going to the system Verilog, we have four states. Okay, so in Verilog, two state data types only we are having. Okay, all these two states only. In these two states, the default value is 0 only. We are getting the value, default value is 0. Okay, nothing else. Now we will explain that what is the net data type. Okay, net represents the physical connection, I told you that. Okay, in between the any hardware elements we are using, so that is the physical connection we are using. Okay, so it cannot store any value, it doesn't store any value, just this is the source 1 and source 2. In between the source 1 and source 2 we are connecting some line. So for that purpose we are using a physical connection, that is the wire we can use. Okay, so wire is generally used for continuous assignment. I am telling you, continuous assignments or combinational circuits. Okay, so we use it for combinational circuits. Why combinational circuits means it doesn't depends on the value. So whenever you are giving the input, we are getting the output. So output is doesn't depends upon the input here. Okay, so while driving the input value, suppose 0 0 I am driving, you are getting the output is 1 here. Okay, this is the NAND gate operation. And then you are driving the different values, means that is the problem. Okay, in the net type most of the values are getting some conflicts. While when you are getting the conflicts means same wire I am using this. Okay, so as a wire y, Okay, assign wire y equal to a and b. Okay, while a and b values I am driving here. Okay, so sometimes I'm driving 1, and at it next time I'm driving 0 without any delay. I'm driving 1, initially I'm driving 1, after that I'm driving 0 means I'm getting the conflict, unknown value I'm getting. Okay, don't drive the values too differently. So suppose while you are getting some conflict means, so your driving value should be same. Okay, without getting the conflict. If you are getting some conflict means you are driving immediately. See, y equal to assign y equal to a. Okay, while getting that, see, this is the conflict represented, y equal to a, y equal to b. Both are driving at the same time. Which value I need to take here? Clear? Which value I want to take here? Or supply 0, supply 1. Which value I want to take here? Okay, then I'm getting some conflict. Suppose week 0, week 1, all these values are there. Okay, at that time you are not driving. So single wire you are using means, okay, this is wire and representing y. So this y will be constantly maintained y equal to a. Okay, and some delay you can give. So delay will be represented with hash 10. hash Hash we are representing the delays, some hash 5, hash 2, hash 10. So in this way we are representing, and y equal to b you are representing means, so initially 0th time delay I am treating y equal to a, and then after some delay y equal to b. This will be a load. So immediately I am driving y equal to a, and then after that y equal to b. So which value I want to take here? Then I will get the conflict. Okay. So some error will be getting, some expropriation error we are getting, and then that is the wire we are writing. Okay, WAND means wire and. Okay, in I2C, I told you wired AND gate we are using. Okay, so in this wired AND gate, which one is taking low, that will be active mode. So because 0 and 1 means wired AND. Okay, it is AND gate. Sometimes you are driving 1 and sometimes you are driving 0. Then there is no conflict will be getting here, right? So we will get the output either 0 or 1, because you are driving. So y equal to 1 and then y equal to 0. So this is wired and I am taking that. So band. Okay, this band. So y equal to a and y equal to b. So after that some delay, a equal to 1 I am driving, and then b equal to 0. Okay, in this way you are driving. Then wired and gate a and b I am driving. So 0 and 1. What is the output I am getting? So 0 here. Okay. So in that way, wired AND gate, and then wired OR gate. Okay, band, OR, and then wired. After that, these are the tri-band, tri-wire. Okay, so these are the different type of wire data types we are using. Okay, so range, there is a storage value. Wire there is no storage. So wire don't have any storage. Range having the storage value. Okay, so wire is used for continuous assignments. See, data flow model we have assigned, right? So how we are assigning the values for the data flow? The keyword is assign we are using. Okay, assign y equal to a and b. Okay, in this way we are assigning the values. Similarly, OR get your writing means some simply assign, okay, y equal to a or b. Okay, in this way we are assigning them. Simple keyword. So this combinational circuits are always called as continuous assignment. Okay, for continuous assignment type we are using wire. There is no storage. And procedural assignments, that is always and initial blocks, we are getting that we are using reg, and then use it for continuous, and then use it for variables. There is no uh, sorry, connections, yeah. So wire connections, and then default value for wire is, if you are not giving any value means you will get the high impedance value. So this is the stable state and you are getting to high impedance state. Okay, so we are getting some high impedance value. Otherwise your ridge, you are giving ridge, you are not connecting any value, you will get unknown value. Okay, so these are the default values. While you are not assigning any value to this, so then you will get the default values, unknown value like x. Okay, and these are the examples where y and then assign y equal to a and b for the continuous type of assignments. Okay, and then always at the rate posage clock, and we have different type of always blocks in the procedural assignments. Always at the rate star we can use, and then always at the rate posage clock, and always at the rate we are using always at the rate some variables list a or b. Okay, in this way we can use. Okay, a or b means, so after while changing the a value or b value, we will get the some values. Okay, whenever we are giving some condition like y r equal to d, you are assigning that means d flip flop you are assigning. That means I need to check this d flip flop for every clock edge. That's why he is using some posage of the clock. Okay, fine. This is the where we can use the wires, some interconnecting the modules and combinational circuits, continuous assignment, and then tri-state buses. All these things we are using the wires to build the multiplexer, demultiplexer, decoder, adders, half adder, full adder. All these cases we are using wire. Okay. So wire cannot be assigned any inside the initial begin block and always block. Always and initial begins are used for procedural assignments, and this is not used for continuous assignment. Okay, at least one driver we need. One driver means suppose x equal to 0, x equal to 1 I am driving, and x equal to 0 you are driving. At least one value we need to give. Without giving value, you are not driving any value, you will get the high impedance value. That is the wire representation. Okay. So the combinational circuits and then connection data path connection purpose, we are using the wire. Okay. And then reg data type. What is the use of reg data type? Reg is the storing the values, right? So it is having the capability to store values. Okay, reg is a data type used to store some values. And procedural assignments purpose we are using the registers. That means inside the always and then initial we are using this reg type of data types. Okay. So the key idea is to store the values. Wire only reflects the driven value. Okay. So whatever the wire value we have taken, wire A, wire B, all these values will be reflecting here because in the range we are storing some value outputs. Suppose inputs I am driving A and B here. Okay. Input wire I am taking wire A comma B, and then range Y I am taking. So this range wire can be driving. Okay, so because in wire y, sorry, in range y, range is the output variable, which can store the values of inputs, right? A and B is the inputs, it can store the values. Okay, use it for combinational circuits, and then must be assigned for any latches or any flip flops. So we are using the bridge type of storage devices, and we can avoid wires while storing the values in latches. Okay, see, I told you, right? So stores the values unlike the wire, and then it can be procedural blocks. In the procedural blocks we have initial block and always block. So initial block one time in execution. So in one time we can execute the initial begin. So initial begin you have taken means in the one time only it will execute all the values. Okay, inside the initial begin, what are the lines of codes are there? All are executed at one time. Okay, so that is the initial begin block. And always means it will whenever it changes the sensitivity list. Suppose you have taken always at the rate some A or B or C you are taking. Whenever A value, B value, C value changes, okay, A equal to 0, B equal to 1 and C equal to 0 you are taking, okay, and then A equal to 1, B equal to 0, C equal to 1 you are considering. At that time it will be changes, okay. So every time you are writing some condition inside the always begin block, see, you are writing always star. Suppose we have more number of sensitivity lists. That means if you consider AXA protocol, if you consider AXA protocol, AR channel is there, AW channel is there, R channel is there, W channel is there, and B channel is there. That means response is there, write data is there, read data is there, and then write address is there, read address is there. Each and every channel have their own signals. Then I don't know what type of signal I forgot to represent. At that time, I'm representing this star means this star will consider all the signals. No need to mention A, B, C, D up to and then X, Y, Z different variables you are considering means those values don't want to mention. Just simply you need to mention the star. The star will take care of all the values. Okay. So where we are using the registers, I told you that. So for combinational circuits and sequential circuits are also we are using the range. Okay, so combinational circuits always at the rate star we are using. Sequential circuits means with respect to clock we are using. Okay, and then latches we are enabling the pins by using the enable pins. At that time we are mentioning the sensitivity list. Okay, each and every time. See, if A and B are changes inside this always block, we will write the conditions related to A and B. Okay, if A greater than 0, this condition is true, then Y equal to B value is assigned. Or else I am taking that Y equal to C value. If condition is true, then inside this condition I am taking that. Okay. So in here, if you want to write else condition, you can take that. Otherwise, you don't want to write the else condition, then you can using the else condition for that because A is equal to 0. Okay. If you are taking the A value equal to 0, so then if you are missing the else condition. Okay. So any value you are taking means then I'm checking the condition for this. Okay, see, always at the rate posage clock, so every time we are checking the D flip flop, this is the D flip flop, and then clock signal I'm giving that, and then output I'm getting that. So D flip flop means whatever the input we are taking, that output we are getting, right? So my output is Q and assigning that input to Q. Okay, D is 0, your output is 0. D is 1, your output is 1. Okay, at that time I am using this always at the rate passage clock. Every passage of the clock my value is changing. So Q is a register and it can create the storage for you storing the value of output. Okay, for every clockage of the data. See, these are the differences between the wire and range. I told you, right? So, wire is used for driving the range is used for procedural assignment. Wire is used for continuous assignment. So, this is the procedural blocks, initial always, and then continuous always. We can use assign keyword. Okay, assign is also keyword. Okay, so assign y equal to a XOR b. Okay, XOR is represented with cap in Verilog.
Source value, unlike wire, means it is not connected to the wire.
Yeah, if you are not connecting to the wire, so we will get that default value is 0 because here this two state variables we are getting the values are 0. Okay, so default values we are giving something like all the registers we are getting unknown value. If you are not giving any value, so you are getting the unknown value, that is the default value. Remember, for register default value is unknown value, for high for wire unknown value, sorry, default value is high impedance. Understood? Register and wire. So these are the examples of register data type. Okay, simple D flip flop I am writing here. So
Impedance means what?
High impedance means we cannot judge the value we are getting 1 or 0. Okay, so that is the high impedance. This is the bus stable state and it is coming to the middle state. So it is not going to high and it is not coming to low.
Yeah. Constant value.
Yeah, that is the resistance. Not constant
Not
value.
constant.
Constant is
Unknown
different.
value.
Constant is different. Unknown is different. Unknown is means x value. See, your your wire is there. If switch is there, in that switch two wires are connected. That means short circuited is happened means your the switch is not working.
Yes, sir.
If you put the plug, the current will be coming. That is the high impedance state.
Yeah,
Okay,
that's-
always on state it is coming. Okay, so that's what. See, D flip flop always at the rate positive clock Q equal to D. So just simple assignment. That is the D flip flop assignment. And then complete code for combinational and sequential circuits while you are using some combination circuits like A, X or B operation I am writing. And similarly, for some different always begin blocks we can use. For one for combinational circuits and one for sequential circuits. And don't use always at the rate postage clock in two different blocks. Then it will get some conflict because you are driving two always beginning blocks means which one I want to drive first. I don't know. So then simulator will get the conflict. So don't use multiple always begin blocks for combinational or sequential. If you are using if you are writing combinational in one always at the rate some values in that only always at the rate star in that only you can write all the combination circuits for AND gate one combination circuit, XOR gate one combination circuit, and OR gate you are writing one combination circuit. That will be not allowed. Okay, you will get the conflict. Unknown value you are getting. And similarly, D flip flop you are D flip flop you are using one combination one sequential circuit always begin, and then RS flip flop you are using another always begin. Okay, so at that time you will get the conflict. Clear? Because I'm driving two different values, I'm getting the conflict here. So then latches we can use the select lines or input sensitivity list. Okay. So latch is always used that always at the rate and then we have a sensitivity list A or B or C in this way we can write the sensitivity list. See here I am designing a multiplexer based on the select line. Every time select line changes means I am getting the some value. So just 2 by 1 marks you are designing. So I told you that XOR gate how you are designing the 2 by 1 marks means. So this is my 2 by 1 marks. Okay, A, B, two inputs I am giving, one select line, one output I am getting. So XOR gate means A, B, two inputs and then output is 0, 0 and 0, 1, 1, 0, 1, 1. 0, 0 means output is 0, 0, 1 means output is 1, 1, 1 means 1, 0 means output 1, 1, 1 means output is 0. Then I am designing the multiplexer in this way. So because 2 by 1 marks, 4 inputs are there. Okay, one is I naught and I1, I2 and I3. So 4 inputs, one output I am getting. Okay, in this output, this is the output, right? Okay, so where we are getting ones here at the 0, 0 means I naught, 1 means I1, 2 means I2, 3 means I3. So for I naught, your output is 0. For I3, output is 0. Okay. So I naught and I3 are connected to ground. Okay. So 0 and connected. And then I1 and I2 is connected to high voltage 1. That is the XOR gate representation. In this way, you can represent any type of combinational circuits by using 2 by 1 multiplexer. Exclusive NOR gate also you can represent. You need to remember the truth table, right? And these are the registers behaviors like combinational circuits always at the rate star we can use or sensitivity list you can represent.
Both of them.
Sure. This is
4
4
4
into
into 1, sir.
see two. This is 4 plus 1.
4 inputs.
4 into 3.
Okay. You can take 2 by 1 multiplexer here. Okay. So this is 1 2 by 1 multiplexer here, and then this is I naught and I1 will be there, and some enable pin you can take here. So this enable pin will be 0, and then upper one will be activated, and then another multiplexer you can take. So lower one will be activated. Again you can take the another two values.
Yes, sir.
Okay. So yeah, so AB value enable pin is there. So then he can take the value like A, B values. Okay. So enable pin is 0, you can take 0 0. Enable pin is 0, so 0 1 you can take. In this way you can consider the values. Okay. So 2 by 1 mux we can represent the 4 by 1 mux. So 2 by 1 mux we can use. That will be converting to design 4 by 1 mux.
Yesterday in interview they asked this question.
See, these are the scenarios. We are using combination circuits and then sequential circuits and then latches and initialization of the blocks. What are the initialization of blocks? Initial block we are using. Okay. So here always sensitivity list. What are the sensitivity lists? So these are the A, B values we are representing. For latches or any combinational circuits, we can go for this one. And then sequential circuits always at the rate posage clock or neg edge clock we can take. Every edge of the clock it can be changing. Okay. See, combinational circuits are always used for blocking assignments. I will tell you that blocking, what is blocking and what is non-blocking. Blocking is always represented with equal to, and then procedural assignments and then sequential logics are always used for non-blocking. Okay, non-blocking means less than or equal to we can use. Okay, so that means whatever the variable, suppose y equal to d I am representing, so this is non-blocking, and then y equal to d, this is blocking representation. Okay, where we are using I will explain the next slides, further slides we have, right? So at that time we will explain. And then behavior, what is the behavior? Input is changes, every time it is changes means these values will be changes. That is the combination circuits. And then every clock edge of the updates every clock edge. What is the posage clock means? Every clock edge. So you are considering the clock signal, so this is the posage of the clock, this is the posage of the clock, this is the posage of clock. Every posage of the clock d value will be changes. Okay, so d value will be changes, this is the d value. In this way we can assign the values. Understood what I am explaining? And scalar and vectors representation same. Similarly, we are writing the registers and why. Okay, in this why we are using the data types means data types it can store the values by using the variables. We are assigning the variables, that variable can store some values. That is the purpose we go for the data types. In that net type is there and then register type is there. So in the previous slides, we are using only scalar variables, var a and then range b. In that way, we are using. Okay, a b. So this is scalar type. That means there is no capability to store the value. So single variable can be stored either 0 or 1. Okay, you are not mentioning the value. That means you are storing the 1 bit value here. 1 bit means 0 or 1, and it can be 0 1 and unknown or high impedance also it can be stored. Okay, so you need to some controlling signals. Then this is the scalar representation. Now I want to store some values more than 1 bit, then we can go for verbose. Verbose or vector. Vector means it can store multiple bits. How can you represent the vector means suppose a is a variable. In this variable I am representing, suppose 2 bit I want to represent 1 down to 0. 1 down to 0 means this is the MSB bit and this is the LSB bit. Okay, so from MSB to LSB you are represent 2 bit means, so how many combinations you will get? 4 combinations will get. Then what is the capability of store this value? A can store 0, 1, 2, 3. Up to 0 to 3 values it can be stored. That is the verbose representation. Okay, so that is the wire. And then scalar means single values it can be stored, and then vector means it is the multiple values it can be stored. Okay, so you can store the address, data, buses and registers. All this can be stored in registered data type. See here, data I am using, that data is a capable of 8 bit. Okay, that 8 bit means 2 power 8. 2 power 8 means up to 256 it can be stored. That means this data I am assigning the value. So assigning the value, that is 8 tick D 2 3. In that way I can represent the, I can store the values. 8 bit, right? This is the 8 bit storage. And don't assign 12 bit octal 3 2 1 4. In this way don't assign, because this 12 bit is can't store this data type storage, because this vector is stored up to 8 bit only. Okay, and it cannot cross the value. Suppose if you are assigning some value like what is the value, uh, 8 take hexadecimal value uh, more than f value. So f we are representing. This is also not storing, because it can store up to 13 12 bits here, but you are capable to store 8 bit only. Okay, your capability to store 8 bit and you are assigning 12 bits, that is not possible. And this variable can store up to 0 to 255. That means 0 can store, or 100 you can store, or 155 can store any value. Okay, so in this way, so 8 bits are there. This is the width we are representing. Okay, if we are representing data before that some width you are representing, then that is the capable to store 8 bits. Okay, so 8 bits it can store starting from 0 and ends with 7. So all zeros it can store, or all ones it can store. Okay, so that's what I'm representing. See, I'm representing 8 tick A, sorry, 8 tick 4 2 I'm representing. So 4 2 means, so these 4 bits we can represent, and then another 4 bits. So what is the value here? 4 2 means 0 1 0 0, and 4 means 0 0 1 0. Okay, so in that way it can store the values. Suppose you are storing 7 down to 0 means 7 is the MSB bit, and you are storing like 0 to 7 means that is ascending order. So starting from LSB and ends with the MSB bit, most significant bit. That means you need to write the variables from LSB to MSB. Okay, remember, but don't use this one. Many times we are using MSB to LSB only, 7 down to 0. This way only we are using. And don't mix these vectors. Suppose A is using some 7 down to 0 and B is using some 0 to 7. Don't mix these vectors type. Okay, so this type of vectors are don't mix. And another way also don't mix this. Okay, like A is some 7 down to 0. Okay, A, and B is 2 down to 0, and C is 0 to 1. Don't mix this, because you are assigning the values in the further values, then it will get confusion, because you are seeing 0 to 1 means, so LSB value is assigned to MSB, MSB value is assigned to LSB, then you will get some confusion which value I need to take there. Okay, don't mix them, right? Remember, these are the vector declarations, right? So from MSB to LSB name, and then MSB to LSB name. So in this way, different examples I am representing. Wire I can also take, or reg I can also take that. Okay, so this is the width. that is the capability to store the 8 bits values and MSB to LSB. And this is the LSB to MS, different values I can store here. So what is the value here? 1011 means 11, right? 11 means B. And then 0011 means 3. Okay, B3. B3 hexadecimal value, suppose 8 tick hexadecimal, B3 I want to represent. So this, in this way we can write the values. Okay. See, some concatenations, the operators will explain you. So what is the concatenation and then replication. So in the further slides we will tell you. Okay, don't go for this concatenation operators here. So this is the example. You can create one account in EDA Playground and write some codes related to regs and wire. Reg is a storage capability. What type of values it can store? You can write one just a simple test bench only. Module name, and your data type. You can take any data type and then write the values. After that, you can display. Is that displaying this value or any value you are getting? Then you can check that. That's it. Just module and then some checker. After that, writing some value, driving some value, and display. Okay, so this code you can practice. Clear? See, these are the driver. So this driver A, so I told you that this is the driving A. Okay, and similarly y equal to A, I am assigning that, and then without any delay y equal to B I am assigning means, so then my driver will get conflict. Okay, which one I want to drive, A or B? Okay, so that's what driving the conflict will be there. So this is the summary of scalar and vectors. So scalar is a single bit, vector is a group of bits, size is single bit, 1 bit, and then it is storing that starting from 2 and ends with infinity. Okay. So and then values can be stored 0, 1 and x, z. Okay, here the combination of bits. So 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, so 1, 1, 1. So in the combination of bits it can be stored. Okay, any values. Say range where we can use single values only. Here verbose representation. Verbose are vectors, both are same. Okay, clear how the registers are represented here. Then scalar vectors, this is also another part. See, while driving the different type of bits here, single bit you are driving, that is the driver A, and you are driving multiple bits, that is bus with 3 down to 0, bus 3, bus 2, bus 1, bus 0. Suppose you are writing 8, 7 down to 0, that means 7, 6, 5, 3, 2, 7, 6, 5, 4, 3, 2, 1, 0. In this way we will drive the values. Okay, starting from MSB to LSB. And suppose you are driving 0 to 7 means, so 0, 1, 2, 3, 4 and so on. So I will drive the values here. Okay, so where we are using common operators, we are using bit access, that syntax is vector of I or data of 2. In this way we'll represent that, or we can represent some MSB to LSB. So this is static and this is dynamic, changing. Static means only single variable we will represent. Okay, and the dynamic means we will represent different values, and then result will be stored as 0 or 1, and then these are the static vectors, only 0, 1, x and high impedance values will be stored. This is 4-bit vector, like 7 down to 4 means 4-bit, or 0 down 7 down to 0 means 8-bit vector. And concatenation means combining the different variables. Suppose I want to combine A, B, so just concatenating A comma B. That means A value is 4 tick B 1010, and B value is 4 tick 11 B 111. Then I am getting the output y equal to A concatenation B, and I am getting the output like 8 tick B 11. So first A is written, right, 1010. After that B value 111. So I am combining the values. That is the concatenation operator. Okay, see, I'm replicating also. Replicating means how many times I want to replicate it. Suppose I want to replicate a value 4 times, then 4 tick of, so this is the 4 tick representation, and then inside that I want to represent a. So that is the 4a. So don't use the tick here. So how many times you want to replicate it, you can write here, and what type of variable you want to replicate it, you can write inside the brackets. Then 4 times a value I'm getting here. Replication, that means repeating some particular value in your hands, that is used by the repetition operator. Suppose repeat of 5 you are using, that means same value you are repeating 5 times. Repeat of 10 means you are repeating 10 times. So these are the examples of a single bit or one bit representation. 0 0 don't represent that. Okay, that is not used. Okay, S is representing. Nibble means what? Nibble means 4 bits, right? Half of the byte. So nibble is it is capable to store 4 bits, and word is 16 bits, and double word is 32 bit. Sign byte is 8 bit, and reserved purpose. So different type of variables we are representing. Clear? Any doubt from this? So this summary already explained in previous slide. So this is the basic example for registers, how we are writing the data, and then different either posage clock or negate reset. This is asynchronous reset. Sometimes they will call it as asynchronous reset. That means you are using the clockage, or you are using and label triggering also. Okay, so either 0 or 1. Okay, sorry, this is 1 and this is 0. Okay, so label triggering. Asynchronous reset means I'm utilizing the postage clock and negate reset. That is the asynchronous reset. So for this design, you are writing some test bench. Just test bench driving the stimulus to your DUT. Is that working fine or not? You are testing the design by using the test bench. That is the test bench usage. So simply what he is doing here, just see the code. Just he is taking one driver data, that is 8 bit, okay, and then always at the rate postage clock. So clock and reset he is taking, and then output rate. Okay, this is the registered output he is taking. So registered output, so registered variable he is taking that. That register is populating the value. So how it is populating value? During reset value, the data is 0. And then during releasing the reset condition, I am assigning the incrementing the value here. So just data is incrementing that data plus one value. That is the registered um, array. Okay, registered array we are using there. So this is the static array, packed array we are using. The packed array means variable size is represented, the size is represented before the variable name. Okay, unpacked means the size is represented, suppose data I am representing here, the size is represented after the variable. That is unpacked. We will explain later, packed and unpacked. Okay, just simple. He's driving one driver and then assigning some values, then he's testing that flip module, some test bench name initial begin, in that reset condition and clock reset condition is taking initially. After releasing the reset, he is assigning some values, generating the clock value, and then monitoring the value. Then he is not giving any value here, not driving the any value. If you want to drive value also, you can drive. So data equal to some 8 tick hexadecimal A, and then data 8 tick hexadecimal some after 10 seconds delay, 8 tick BB, I'm assigning that, and after 10 seconds delay 8 tick 3 4, I can assign that. So then it will increment that. Don't why he is not assigning means it is automatically incrementing the value, right? So up to that increment value we will get. So 0, 1, 2, 3 and so on. So different values we will get. That's why he's not assigning any value. Okay, if you want to assign manually, you can assign that. Okay, so just a timeout value, and then what is the hexadecimal value is writing, output value is writing, and similarly time, what time you are getting, that time is also printing here. Okay, clear? Register for static values and verbose values.
Yes, sir.
Okay, so you can see up to this. Tomorrow we will discuss this module codes and what are the module codes and all these things we will explain.